Thank you for coming. My name is Jeff Hagopian. I'm at College of the Desert, and my talk is going to be on using Stroustrups. Am I missing an R there? Oh my goodness. Yeah, where's my my editor when I need him? Programming practices and principles is the name of the text in C++. And it purports to be an introductory text for C++, and so I perused it last summer and said, let's make this work. I've grown to like it more and more, but it is a little bit different. So let's see. If I do the page down, it doesn't work. Huh? How about this page down? Spacebar? Okay. Right arrow. This is just a PDF. Let's see. So.
Over. Do that guy.
This guy?
Oh, no, you can make it full screen again.
Okay.
That little thing at the top of it.
Right there. Okay, so I can just go plus.
No, that'll do.
Oh, okay. Well,
the down arrow.
The down arrow. Okay, so this is the basic structure of my talk. I'm going to talk a little bit about me. If that goes on too long, just pull on your earlobe and I'll. Then Stroustrup's philosophy and my implementation of it. So when we get to talking about me, it's really the history of my program at College of the Desert, which I think is a little unusual. I come from a math background. My degree is Master of Arts in Mathematics, and I obtained that in 1986. And I had some training in computer science. I had by that time taken Pascal here at Cal State San Francisco, and I have studied Fortran 77, and I was a hobbyist. I had an Apple II and had learned to hack the Apple II in various ways that were interesting to me. Okay, so the arrow, huh? Then after graduation, I actually got employed doing, I guess, what you would call computer science. It was, I had two jobs in Los Angeles when I first moved there. One was doing database management with Lotus 123. Anybody? Yeah. And this was for a travel agency. It was one of these sort of boilerplate numbers where people are on telephones trying to sell travel packages. It was awful. But it had a nice view on Venice Beach, so that wasn't too bad. But the other job was really interesting. I worked for some friends developing software for Hollywood. And my job was to organize the accelerando for the orchestra. And, the orchestra would be looking at a blinking screen, which would blink for each beat, right? And so they would synchronize their playing to the blinking on the screen, and you had to have a certain number of beats for this event in the music and that event in the music, and this frame in the film and that frame in the film, and you had to make a smooth transition from one pace to a higher or lower pace. And that was fascinating, but it didn't pay all that well, and I was just sort of a flunky in the firm, offbeat systems. And so I had to get a real job. So I got a job at Pasadena City College, full-time temporary, teaching mathematics. And that lasted for a year or so. Then I got a job at College of the Desert, full-time permanent. But I have been there since. No problem. So I've always been sort of involved in politics, and I was early on academic senate president. And as such, when I saw the curriculum being manipulated, there's always been sort of a conflict between the CTE version of C++ being taught at College of the Desert and the scientific computing version taught through the physics department originally. And when the dean said he was going to cut the physics department version because it's really duplicating efforts, and why be inefficient in that way, I said, no, those, you don't understand. Those are different courses. There's business and there's science, and they are different. And so I was able to save that course. And as my reward, I guess, in some sense, later on when they needed a teacher for the course, they picked me. This was before minimum qualifications were widely applied and understood, I guess. And so, you know, say, hey, I can do it, I'll do it. And so I did for a number of years. And then the people in the business department, the CTE version of the course, said, well, guess what? There are minimum qualifications and we don't need them. So we're not going to teach that course anymore. So at that stage it became, well, me and the physics guy who were teaching the course said, okay, well, we need a computer science program. And we created a program, with, you know, a degree program, so you can get an AS in computer science at College of the Desert. And people have. You know, it's a 2-year program. The minimum requirement for computer science 7A, the introductory course, is trigonometry. And then for the next course, it's pre-calculus. So that's sort of the math sequence. And so we're hoping that students will take these courses sort of together in sequence. That's kind of happening. And, you know, you don't obviously need trigonometry for C++, but it's a level of sophistication about how you're thinking that is important, I think, to achieve at that level. You know, obviously there are differences of perspective on that. So I had, over the years, at College of the Desert, we have a very generous program for sabbaticals, and I had taken 2 one-year sabbaticals. The first year I did study of cryptography, which was highly involved in computing, and the second one was in scientific visualization. Again, a lot of computing. And so based on that, and my study later on with Stephen Block, he's at Adelphi University, and he has a program in Racket, which is also known as Scheme. Anybody? It's a programming language, and it's kind of an interesting programming language in that it's not iterative; it's more recursive. So it's built from the bottom up on objects and recursion, and so it's a different sort of philosophy about computer science and programming that I embrace, but you know, if you want to have a program that's going to transfer to you know, UC and whatnot, that's not going to work, right? So as much as I would like to do that, we're stuck with C++. I suppose there are people who do Java, but in any case, based on that, I was granted equivalency, so I now am meeting the minimum qualifications officially. And so is the physics guy. Apparently, if you look at the minimum qualifications for a CS professorship, there's some question about whether there's a comma between engineering and mathematics or not. But in any case, we have certification now, locally in any case, and so I'm glad for that. And so we have our program at COD. If you're interested in following my work, or if you want to get this talk, I basically, this is my repository for everything. And in fact, this talk is there. So we take a quick look. Let's see. Uh-oh. Security warning. Yeah, we better allow that. Okay, so this is my website, and I'm not a very good HTML coder, as you can see. And I also have a terrible aesthetic sense. So the background I will explain maybe later if we have time. But yeah, if you go over to various musings and reports, that's a link where you'll find another link that contains this talk here. Okay. All right, so let's see if I put another arrow down. Okay, so let's move on to Stoustrup's. It's a Stroustrup, not Stroustrup. If you want to hear him pronounce his own name, he has it on his website. In any case, I'm going to try to summarize his article, which, in fact, this is a hyperlink. If I hover over here, yeah, this is a hyperlink to where you can actually read this article that he describes his philosophy in more detail. I'm going to more or less summarize that here. And he defines programming as a means of making ideas into reality using computers. Okay. And he claims, and this is from his experience, he teaches at Texas A&M, that what he sees largely in U.S. universities is what we produce in computer science is really not so much what the industry, if you like, needs. Industry being all kinds of different things, like nonprofit organizations to local small businesses and whatnot. What do people out there need in the form of programming? Well, probably not so much algorithmic complexity and data structures as you know, a program that will do what that organization needs done, which involves software development and perhaps not so much subsurface luminosity, he suggests. Maybe that those kind of topics can be played down. So he says fashions come and go so rapidly that only a solid grasp of the fundamentals of computer science and software development has lasting value. Industry wants software developers more than computer scientists and engineers. Now that's him saying that, and so that's his philosophy or his perspective at this stage. Preferably, an understanding of programming extends to several kinds of languages. Declarative, scripting, machine level, and applications, embedded systems, text manipulation, small commercial applications, and scientific computation. And this is a direct quote from his paper. Language bigots do not make good professionals. I think that's a gimme. All right. And here's another quote from him. How's that? Language bigots? Yeah. I only do Java, or I only do C++. Right, Visual Basic. Oh, yeah, that's terrible. In fact, I think Visual Basic was what we used for the Accelerando software way back in the day. That was it's been around for a long time. Yeah. So he says, for many, programming has become a strange combination of unprincipled hacking and invoking other people's libraries with only the vaguest idea of what's going on. The notions of maintenance and code quality are at best purely academic. Consequently, many in industry despair over the difficulty of finding graduates who understand systems and can architect software. And so it's kind of a Rube Goldberg. Now, that being said, you know, I've learned a lot here at this conference yesterday. It was marvelous. You know, Sam Brown, what he was doing, obviously hacking, right? Good stuff, and I learned a lot. And so, I'm not sure if he's using hacking in the sense that we often do. Hacking is one of these sort of amorphous words, which I think he means more like being a hack than hacking. In any case, he says that the study of software includes small group scale, teams collaborating on different parts of a project. And that lays the groundwork for scaling up and working on programs with millions of lines of codes. And that's kind of where he's going with his text. He's trying to lay the groundwork for a solid foundation in building systems and software development. Okay. Comparison of programming languages. And I think this third item is really just emphasizing the first one again. So he recommends this, and this is an ideal I have not met, which is getting students to collaborate on projects. It's hard. You know, you'd think it'd be easier because you have fewer projects, right? You know, you divide the number of students by 3, and then you have 1/3 as many projects to look at. But then, you know, you have to, yeah. Validating individual work, I guess. Peer review. I would like to hear your ideas about that because I really want to go there. So if you, okay, yeah, I'd like to hear what you're doing there. So peer review, yeah, my sister-in-law teaches in health science, and yeah, she said, well, why are you working so hard? Just use peer review. What's that? Okay, so I'm all ears. That sounds like a good idea. Okay, so here's a picture of the cover of his text. The freshman programming classes at TMU are based on his text. Its preference table of contents, lectures, slides, and other supporting documents can be found there. That's also a hyperlink. Yeah, so he's very forthcoming with supportive materials. Let's see, I have actually a PDF of the book up here, I think. Yeah. The book is actually fairly inexpensive. I think it's a little over $50 for a fairly large, solid piece of hardware. So here's some items from his book. I guess I kind of wanted to go back to page 135 for the first look at this. So maybe I'll jump over there. Oh, 35, huh? Okay. But we'll get back to that. Yeah, if I suppose we could jump to his site. This is what it looks like. You can see he's got his style guide, instructor's guide, lecture slides, selected solutions, which you probably want to look at if you're assigning problems. Don't assign those, I guess, right? Or if you do the follow-ups as well. Okay, so we can talk more about that later. Okay, so the approach is a depth first, which means that he puts a lot of objects out on the table before you fully understand them, which is kind of like the way you learn C++, right? You begin to use the IO stream library before you understand all its elements. Who really understands all the elements of the IO stream library, right? CIN is the tool, CIN and COUT, that are fairly robust, complex tools, which you can use at a shallow level or go more and more deeply into it. The first 11 chapters, which Stroustrup does in about 6 weeks. I'm kind of amazed at this. Really? So I took 15 weeks for the first 11 chapters, and I didn't really get to chapter 11. So 16 weeks with the final exam week at the end. So obviously my students are going to be a little bit less sophisticated maybe than Texas A&M. I'm not really familiar with Texas A&M. He claims that the students come from all over the place. In the Coachella Valley, where I'm from, where I teach, I should say, it's one of these areas where very few households have somebody with a bachelor's degree in the household. So it's underdeveloped, you could say, underprivileged, and so I get a lot of students who just have never experienced this sort of sophistication or erudition. But in this 11 chapters, he covers objects, types, and values, computation, debugging, error handling, and the development of a significant program, which is kind of why this picture of a calculator is here, because what that significant program is an interpretive calculator. You enter an expression, an arithmetic expression, and the idea is to develop from the very beginning, step by step, a program which will interpret that following the order of operations. Actually, the first version of the calculator just reads left to right, and students are sort of offended by this. No, you have to do multiplication first. Oh, okay, well, we'll try to accommodate that, and that's the next improvement, right? So it goes very, very step by step through lots of iterations and improvements. Redesign, extension of functionality, and testing. Language technical aspects include the design of functions and classes. Sure. So with that in mind, maybe we should jump back to the text and look at, this is the very first exercise that sort of starts to develop this thread. Oh, actually, that's not it, is it? It's the next one, isn't it? I highlighted the wrong one. Here. Write a program that performs a very simple calculator. Your calculator should be able to handle the 4 basic math operations: add, subtract, multiply, and divide, and 2 input values, should prompt the user to, excuse me, to enter 3 arguments, 2 double values, and a character to represent the operation. If the entry arguments are, say, 35.6, 24.1, and the plus sign, the program should output the sum of 35.6 and 24.1 is 59.7. And then he sort of presages, in Chapter 6, we will look at a much more sophisticated simple calculator. And then in Chapter 7 and Chapter 8, it will become even more and more sophisticated. And so this is, you know, the idea of depth first, that you're going to build a large program going through the process of design. And he talks a lot about the process of design, so maybe we should jump to the next position where he does things involving that. This is the text. And what I like about this text is there's a voice. You know, you can hear somebody talking to you. It's not written by a committee. As such, it, you know, invites reading. Where so a lot of sort of committee-written textbooks, I think, sort of invite skimming. And where's the key box that I need to just read that key box and then jump to the exercises. He says, what do we want from our programs? What do we want in general as opposed to particular features of a program? We want correctness, and as a part of that, reliability. If the program doesn't do what it's supposed to do and do it in a way we can rely on it, it is at best a serious nuisance and at worst a danger. We want it to be well designed so that it addresses the real need. It doesn't really matter what a program, that a program is correct if it does what it if what it does is irrelevant to us, or if it correctly does something in a way that annoys us. We also want it to be affordable. I might prefer a Rolls Royce to an executive jet for my forms of transport, but unless I'm a billionaire, cost will enter into my choices. So yeah, I guess I'm sort of just sampling a bit of the reading there. Obviously, we don't have time to read it in detail, but let's see. At some point here, he develops further into the calculator. Where are we here? So these are, you can see he's got the exercises, the postscript, and a little looking back. Let's jump to page 173. Oh, I think I'm on page 63 when I meant to be on page 158. Is that right? Okay, right. Sorry. Yeah. And throughout the textbook, he has little drills and tries these things, and he really wants you to do these. So stop whatever it is you're doing and try this. So, and I think this is sort of instructive as my philosophy of teaching as well. He says, our hexagon, well, he talks about estimation and doing pencil and paper estimation before you go into actually writing code, right? So what if you wanted to compute the area of a hexagon, right, with regular 2-centimeter sides? How would you estimate this on the back of an envelope? So he asks you to take a piece of paper and scribble on it. Don't feel that that's beneath you. Many famous scientists have been greatly admired for their ability to come up with an approximate answer using pencil and paper. This is an ability, a simple habit, really, that can save you a lot of time and confusion. So don't jump into writing code, throwing code at the wall until you've thought about what it is your program, what problem you're addressing with your program. Okay, well, yeah, again, I could get into more detailed reading of the book, but let's continue on here. Finally, at the end of chapter 10 and 11, an interactive file I/O are explained in some detail. The data types used are bool, char, int, double string, variable length sequence of characters, he advises us, and vector. Let me tell you a little bit about vector here, which is that this is the first semester, last semester, the first semester I've taught without talking about arrays. I said, what the hell? Why do we need these things? They're clunky artifacts that are basically deprecated in C++ now. If you go straight to vectors, they're flexible, they're more robust, and they're just easier to work with and more robust. So why bother with arrays? I guess because, you know, legacy code. So, you know, there are some reasons to, and he doesn't ignore arrays entirely, but he sort of skips straight over arrays and goes to vectors. And you know, once you get to chapter 10, chapter 11, you've basically got all the basics, so to say, redundantly. At this point, the students can, in principle, do simple computations on streams of numbers and or strings. They're now dazed and need a break, and I would have to say that if you've taken them through this much in 6 weeks, they will be dazed. And my students were dazed after 15 weeks. So I think that's probably more an appropriate pace for a community college. Okay. So you know, back to his basic habits of mind. This is what he's looking for as the core for essentially developing, you know, good software development practices. Invariance, interface design, error handling. Let me say a little bit about error handling, this is a topic I've always sort of avoided. You know, the try-catch procedure. What is that? You know, it's sort of alien to me. That's something I was trained in. Of course, most of C++ was developed after I graduated from college, so I'm largely self-trained on most of this. And so, as I say here, these habits of mind are not easily embraced. They were not for me. And students may not go willingly, but these habits are essential to a sound programming foundation. And concepts and techniques are presented through concrete examples, followed by articulation of underlying general principles. Students often struggle grasping the importance of these principles, which are seen as abstract, so repeated application to concrete examples is essential. The style of the concrete examples reflects the principles and can, when imitated by students, lead to later understanding. So it's, you know, you put it on the table and, you know, you try to have the students imitate your own practices in ways that they will then learn to handle errors in a way where you don't just depend on the compiler. You anticipate the kind of errors you might experience, and you use the try-catch. I should mention that central to his text actually is the use of something he calls a standard library facilities.h file. It's a header file which includes everything that you might need, including some special functions that he defines for error handling. You know, vectors is in there, IOStream is in there, using namespace std is in there. So all that stuff that you ordinarily have to write every time you start a program, you just write one line of code, include this header file. I have a little caveat on that, which is that his header file changes from chapter to chapter. So if you're using chapter 5's header file in chapter 7, you get weird error messages. And you think, what the heck's happening here? So you just have to be sure that you update your standard library facilities file. Okay. So outcomes and what's next. So at the end of this part of Stroustrup's course, the entirety of my course, successful students will have no trouble with a problem like this one, which I guess the prompt would be the comment at the top. Produce the sum of the integers in the file data.txt. You know, so this could be a final exam question, and students should be comfortable answering it this way. Yeah. Let's see, I think I've got another statement on this. So the next part of PQ, as I call it, which is Programming Practices and Principles, will be the second part of our course. So we have a 2-semester sequence, 7A and 7B at College of the Desert. And in the second semester, the students should have a lot more fun because they'll be using the full tick, I guess is what it's called, Fast Light Toolkit. graphing libraries. And this has always been an idea. I've really studied OpenGL extensively, but have never been brave enough to sort of bring it into the classroom and have students do graphics using OpenGL. I think with these libraries and with his textbook that will be possible. I haven't done it yet. I won't be doing it next semester. That'll be my partner, Doug McIntyre, in the physics department. But he's looking forward to it, so that's good. I did use something called DartGDK, which was, have you tried this? That was fun, but it's kind of a Mickey Mouse library in a way. But it did allow me to do graphics. I did that one term. And yeah, that's why I abandoned that. Yeah, and no, I think I've got a hyperlink here for that. Yeah. So yeah, this is their website. So it's a whole group of developers, and I think it's got sort of GUI and graphic user interface together with OpenGL, sort of bundled together in a nice usable package. There's something funny happening with OpenGL. It's really not being developed anymore or supported. You know? Yeah. Uh-huh.